Welcome to Learn It Training. The exercise files for today's course are located in the video description below. Don't forget to like and subscribe.
Hello everyone and welcome to Excel 365 Advanced. My name is Joe Patty, and today we're going to be talking about some of the advanced features that open up more complex analysis and automation capabilities within Excel.
Looking to support our channel and get a great deal? Become a member today to unlock ad-free videos. That's right, your favorite courses without a single ad. Interested in a specific video? Purchase one of our ad-free courses individually. Looking for even more? Gain access to exams, certificates, and exclusive content at learnitanytime.com. More information can be found in the video description below.
One of the first things we're going to talk about today is named ranges. Named ranges are great because it allows you to customize the name of the cell rather than addressing it as J1 or B5 or C7. We can just rename them. This works really well for us, especially when we're using them in formulas. That way we don't have to refer to absolute cell reference. We could just name our cells. So let's say we have this Joe's Pizza ledger here, and we want to calculate the taxes. If I was to do this the regular way, I would do equals, multiply the 3063, which is an I4, and I multiply that by the tax rate found in J1. Now we know this is going to work, but then if we go to autofill, it's not going to work because we're now using relative reference when we should be using absolute. So what most people will do is they'll go back into the formula and they'll put in their $ to absolute reference it. This works very well. And then when we re-autofill, we can see the results. But there is another way that we can absolute reference by naming our ranges. So the first thing I'll do is just clear this out, and I'm going to click into J1. You can name your range two ways. You can use the name manager over here, which says J1, and I can quickly click into J1 and rename it whatever I want. I could call it Joe if I wanted to. But you usually want to name it something that's relative to what it is. So for instance, tax rate. Now, naming ranges, you can't use spaces in the name. So if I do tax rate, I can't do this. If I press enter, it'll give me an error. What you can do is write tax rate all as one, or a lot of times you'll see most common an underscore and then rate. So it'll be tax underscore rate replacing that space. You can name it whatever you want though. Maybe you just want to call it rate. But I'll call it tax rate and press enter. Now that I named it using my name box, I can now click into the taxes area. I'll click J4 again and rewrite my formula using the named range. I'll do equals I4 multiplied, and instead of it being J1, it will now be called tax rate. Press enter, and now we can quickly autofill. So you can name one cell, you can name a range of cells. If you're going to name a range of cells, you can go over to the Formulas tab, and inside of that Formulas tab, you'll see the Define Names command group here. This is where you can define a name if you want to do just one off, or if you want to define a whole range of cells, you can select from a selection. You can then use these named ranges in formulas if you don't remember what you named it, or if you want to see a list of all the named ranges, you could go to the name manager. Let's say I didn't remember what the tax rate was. I don't remember what I named it. I can do equals, select, and multiply, and then I can go over to use in formula, which is found in the formulas tab, and you'll see a list of all the named ranges, and I'll select tax rate. Press enter, and there you go. Another great thing about named ranges is you can use it in the entire workbook. So even if I'm on a different worksheet, I could just click, and maybe I want to see what happens if I increase it by 10%. So I'll do 0.1 multiplied. Let's put our equal sign, 0.1 multiplied, and then you can use in formula tax rate. Press enter, and then you could turn this into a percentage. So As we can see, named ranges can help us a lot because now we're not referring to Excel's way of naming cells, like K5 or B3. We're now using our own English language to name our cells. If you want to see a full list of these, you can go to Name Manager and see all of your named ranges here. You'll see I named a tax rate, the value of the cell, and where it's referring to. You'll also notice that it automatically absolute references those cells with the dollar signs for us. Now we just saw that named ranges work really well, but what happens if we want to do an entire data set of named ranges? Well, the good news is that we don't need to just select each time and use the name box. What we can use is something called Create from Selection, which is found in the Formulas tab under the Define Names command group. So if we're going to name more than one cell, this would be a great way of doing it. Let's say that I want to name all of this data. The first thing I'll do is select all the data. I'll then go over to the Formulas tab and click on Create from Selection. Once I do that, it'll pop up this dialog box and I'll say, okay, Joe, where do you want to grab the names from? Do you want the names to come from the top row? Which, yeah, that would make sense. That would mean that all of this data, like pizza, garlic knots, salad, wings, french fries, drinks, would be named item. All of these prices would be named price, and so on and so forth. So that's a good idea to say that I want to use the top row. So I'll deselect left column and only keep top row selected and click OK. Now, if I want to see those named ranges, I could go to Name Manager and look at this. We now have a ton of named ranges: item, price, subtotal. So if I want to quickly do something like this, maybe I want to see how much money did I make total. I could see equals, the sum, tab, and then I could just say subtotal. You'll notice that when you start writing it out in English, that this is what it'll look like when it pulls it in the menu. It looks kind of like a little table with some selected cells, and you'll see the name. And you can quickly select that by double-clicking and pressing Enter. And it'll give us the total of this entire column because remember, all of this is equal to subtotal. If you only select, let's say, from I4 to I8, that's what it says in the name box. It just gives you the I4 that you selected. But if you select I4 through I9, you'll see it neatly displays subtotal because we've used create from selection, which means it took all of these cells and it just named it from the top row. One of my favorite things about Excel 365 is some of the new features, one of them being XLOOKUP. Now you've probably heard of lookup functions before, whether it have been VLOOKUP for vertical lookup or HLOOKUP for horizontal lookup, or maybe you've used, let's say, index and match. Well, XLOOKUP searches vertically or horizontally for a lookup value, and it does it in a first row or a column or a range or even a table. So it looks pretty much left to right. That means that XLOOKUP does replace VLOOKUP and HLOOKUP. And not only that, it's easier to use, and they have some really great built-in features. So let's take a look at XLOOKUP. We'll see here that we have the product name and the price. And all I want to do is, whenever I look up the product name, like notebook, I want it to return the price for me. So I want it to look up notebook and then return the price. Now, if you've ever used VLOOKUP or HLOOKUP in the past, you'll know that right now, the way that our data is set up, this would not work. Because in order to use VLOOKUP, there was limitations. Like, in order to use VLOOKUP, you would have to have whatever the lookup value is, which is the product name. That would have to be the first column, which it isn't here in our data set. And it would have to be in ascending order, which once again, it isn't here. So VLOOKUP would not work. But that's the beauty of XLOOKUP. It replaces it because it looks left or right. You don't have to abide by those limitations anymore. So let's click into B2, and we're going to start this off with our equal sign, and we'll type out XLOOKUP. We'll press Tab on our keyboard next to the Q to open up the parentheses. And if you're new to writing functions, feel free to always click on the FX next to the formula bar here, and that will open up our fun little function arguments box. That way we don't have to worry about putting commas in. We could just fill out the 3 boxes. Now there's 3 main things that we need to fill out. The lookup value. So what are we looking up? We're looking up notebook. The lookup array. Where are we looking for the word notebook? In this list of product names. And then when we find notebook, what do we want to return? Well, the price of it. So those are the only things that are mandatory that we need for XLOOKUP to work. There are a couple other arguments like if not found or match mode or search mode, and those are just extra benefits of XLOOKUP. They're really amazing tools, and I'll talk about them a little bit. But let's start off by saying, okay, how is this going to work? Well, we're going to tell it what we're looking up, whatever's here, which is notebook. It's going to look for it in this list, it'll find it, and then it's going to return whatever's next to it, which is the price. That's it. That's how much easier it is than VLOOKUP. No longer do we need column index numbers. No longer do we need to specify whether it's an exact match. XLOOKUP by default is an exact match. So let's try this out. What is the lookup value? Whatever's in B1. What is the lookup array? Well, from B6, I'm going to use a keyboard shortcut here. Control key, Shift key, down arrow to select from B6 to B73. And when I find it in B6 to B73, I want to return C6 to C73. Once again, I'll just use Control, Shift, down arrow. And that just simply selects all the data to the next empty cell. Now that I have those, I just click OK. And there we go. We find out that notebook is $5. Let's see, how much would be maybe a printer? $100. Okay. What about a binder? $4. So we see it's working perfectly. Now there is so much more to XLOOKUP. For instance, let's say that I type in something like Joe. Well, it's going to give me that nasty looking error, right? And this error simply means that Joe is not in this list. But typically when somebody types in something and they see an error, they think either the formula is broke or they did something wrong. We used to have to use if error, and we would nest our VLOOKUP inside of the if error to fix this. But with XLOOKUP, the really great thing is that they built in what's known as a if not found argument, which means that if it's not found, we could write anything else and not get that error. So if somebody types in Joe, we could just say not found. Make sure you put your quotes so it's a string of text. When I click OK, instead of getting that error, now we get not found. So if somebody puts in, let's say, notebook, it gives us the price. If somebody puts in, let's say, hello, well, then it does not found. And that's going to really just help with the functionality of your function here. So I'll type in printer again, and there we go. We also have 2 other arguments, and I'll just reopen by clicking the FX. We have a match mode. Like I said, XLOOKUP by default is an exact match, but you can do closest match if you're looking at, let's say, maybe like a range of items. But we also have another one called search mode. And this is really unique. From the default, it'll tell you that it's first to last search, which means that when it's looking through this list, it's looking this way. So it's going notebook, pen, stapler, desktop. And we can change that search mode to look from the bottom to the top. So by default, it looked from the top to bottom, but we can reverse it to search last to first. So that's another thing that's really nice. The reason why you may use something like this is because if something was updated in sequential order, let's say for instance down here, I redo the notebook. So I'll just put in 6.9, we'll say notebook again, and then I'll say that I'm going to up the price to $8 now. We'll just say, yeah, I'll update this and call it 8. So now it says $8, which is great. And if I go over here and I type in notebook, it still says $5, right? But if I decide to, what I can do instead is I can rewrite this function. I'm going to now just go to B74 to include that new entry there to C74. Click OK. You'll see it still says 5. If I go to search mode, however, and I decide I want to change the search, right now it's saying 5. If I do a -1, it'll now say $8. If I put a 1, or I leave it blank, then it searches from the top to the bottom, so it hits this notebook first, and then says price for 5. If I do -1, it's searching from the bottom, and it'll give me the updated price, because now it's searching from down here. So that's just an example of why you would use something like a search mode. But yeah, we have so many different options with XLOOKUP. As we just saw, XLOOKUP is an amazing replacement for VLOOKUP and HLOOKUP. We can now break through those limitations that we often ran into with those lookup functions. Now you'll see here that XLOOKUP can also be used to do data mining, and data mining allows for more flexibility for data analysis. Let's say that we have these 3 separate tables. I have one table over here that tells me all the products and the pricing. I have another table here that tells me all of our sales reps and what region they sell in. But then I have this table here, this is my facts table, where I see all the things that my sales rep have been selling. The problem is, every single time, I have to go over and I have to say, oh, Christy, okay, where did Christy sell? Oh, let me look up Christy, there, West. And then I have to type out West here manually. Now you can imagine with a lot of data, and I mean, we have a lot of data here, how long that could take me. So instead, I'm going to use XLOOKUP to do some data mining, where I'm going to pull the data from these 2 tables and then bring it over to my facts table here. So the first thing I'm going to do is click into L2. I'm going to do equals XLOOKUP. I'll press Tab to open up that parentheses. And then if you're new to writing formulas, feel free to just click the FX next to the formula bar, and it'll open up the function arguments box to help you out. So looking at this, if I want to grab the price, how would I do that normally? That's what I always think of first. How would I do this if I didn't have XLOOKUP? Well, I'd probably, if I was looking up price, I see products and price, I would say, okay, product is doublers. I would look here, I found doublers, and I would look next to it and say, oh, the price is $79.95. That's how I would do it in real life. That's how I'm going to do it with XLOOKUP. The lookup value is going to always be what you're looking up by. In order to find the price, we need to look at what are we looking up the price for? The product, which would be I2. Then I'm going to say, well, where am I going to find the product, I2? Well, in this list of products. And then what do I want to return? Well, I want to return the price. And there we go. So that's going to be my function. So now that I have that, let's do it. The lookup value is going to be I2. Now, since I am looking up the price, I know it's going to go to I3, I4, I5, so that's fine. For my lookup array, however, I'm going to say where am I looking up for the product? From A2 to A13. We do want to make sure that we absolute reference this. So you can either use named ranges, which we learned about in an earlier section, or you're more than welcome to just put the $signs in. I like to use the function for key, the F4 on your keyboard. So I'll click on F4 and it puts in the $signs for me. However you want to do this, whether you want to do named ranges or just put the $signs in, you're more than welcome to. For the return, I want to return the price from B2 to B13. Once again, I'll put in my $signs by using my F4 on my keyboard. And when I say F4, I don't mean pressing the F and then the 4, I mean the function keys up top. You'll see F1 through F12 on the top of your laptops. So now that I have that, I'll then click OK. And look at that, I get the price right away. And instead of doing all that work, I'll now use autofill, and it does all the work for me. So sunshine is $19.95, and if we look here, sunshine is $19.95. So we're using data mining, and we're using XLOOKUP to do that. Let's say that I want to grab the price with a discount. Well, since we already have the formula for XLOOKUP here, we can do two things. We can either just copy this formula and then wrap it for the discount, or you're more than welcome to just reference the cell. So for me, I would say price with discount is going to be equal to. And if I just want to do the price with the discount, you don't want to necessarily do price multiplied by discount, because all that's going to do is give you what the discount amount is, which is $2.39. Or if we round it, $2.40. What I want to do is I want to see the price with the $2.40 minused out. So in order to do that, when we write our formula, we're going to take the price, which is an L2, and subtract that from the price, L2, multiplied by the discount. So all it's doing is subtracting that discount amount, which is $2.40 inside of this parentheses, minus out from the regular price, which gives us the $77. And then, of course, you're more than welcome to go through, and now we see the price with the discount. Now, if you don't like the way these two numbers look because they're prices, feel free to select L and M, go to the Home tab, and inside of that Home tab, head over to the Numbers command group, click the drop-down, and choose Currency. That way it looks more like an actual price. So for the region, feel free to do this on your own. You're more than welcome to pause the video and try it out. But then once you're done pausing, let's go over it right now with region. So I'm going to do equals XLOOKUP, press tab to open the parentheses. Once again, you can always click that FX if you need help with writing some functions. You don't want to put the dollar signs, you don't want to put the commas, you don't want to put the parentheses, any of that. You can just use the function arguments box. The lookup value is going to be, since I'm looking up region, I see region and salesperson. So how would I normally look up where Christy's working is I would search for Christy's name. That's going to be my lookup value. I'm looking for it in this list of sales reps names from D2, Control Shift down arrow to D73. And when I find it, I want to return the region, which is in E2 to E73. And once again, I use that keyboard shortcut, Control Shift down arrow, and that helps me to select to the next empty cell. Now I'll click on my lookup array, make sure you put your dollar signs in. And I'm just using that F4 function key to help me do that as a keyboard shortcut, and I'll click OK. Now I can double click, do my autofill, and look how amazing this is. Something that could have taken months has now taken a couple minutes, and we now have a full list of data. One of the next functions we'll talk about is a popular function known as the if function. The if function allows you to make logical comparisons between a value and what you expect, and then it'll return one result if true and another if false. So really it's just asking a question and answering true or false. It's sort of like if you asked me, hey Joe, is it cold outside? Well, if it is cold, if that's true, I'll put on a jacket. If it's not true, if it's false, I won't have a jacket. So depending on what the answer is to that question, whether it's true or false, two different things would happen. Let's say that I'm looking at this bonus review here, where I have the employee's name, their performance rate, and I want to just simply see if they're going to get a bonus or not. Now the bonus is going to be that if they make 3 or more, then they get a bonus. If they don't, then they don't get a bonus. So in order to do this, I'm going to do equals, if, and press tab on my keyboard next to the Q. That will open up my parentheses. As always, if you feel comfortable using the FX button here next to the formula bar, that will open up the function arguments, and that helps out so we don't have to put in our commas. The logical test is going to be the question we're asking. We're asking, did they grab 3 or more here in their performance rating? So I'm going to select from B5 to B10, or if you want to do this on one level, you just select B5, and you're going to say, is it greater than or equal to 3? Now that's true, as we can see here, because, well, it's a 3. So if it's true, now comes the easy part. What do we want to do if it's true? We could do anything. We could put a smiley face, we could say yes, we could say no, we could say bonus, whatever you like. I'll make sure to put it in quotations, which is a string of text, and I'm going to write bonus. Just like that. So now, if this number is greater than or equal to 3, it will say the word bonus. And if it's not, it will say no bonus. Once I click OK, it says bonus here, and then all I have to do is just autofill. And now we can see who met the bonus and who didn't. So you'll see bonus because it's greater than or equal to 3, greater than, greater than, it's not, and it is. So there we go. We now get the bonus right away. The next thing that I want to do here is, let's say that I wanted to see the selection for lunch. Well, the problem is that there's 3 different selections. 1, 2, 3. And as I just said, when it comes to the if function, it allows you to return 2 things. If it's true, it returns something. If it's false, it returns something. So how are we going to do this? Well, we can actually keep nesting if functions inside of each other to come up with more results. So instead of just doing 2 results, we can come up with 3 or 4 or 5 or as many as we want. So I'm going to click into V5. I'll do equals, if, and press tab to open the parentheses. In this case, I'll go over to my FX to grab that function arguments box, and we're going to say that there's 3 selections, and we'll make them up. We'll say that the logical test is that if, we'll start off with the first one, if F5 is equal to 1. Now we know that's not true, it's false. So F5 is actually equal to 3. But if it was equal to 1, if that were true, what would it be? Would it be a sandwich, maybe a cupcake, whatever? I'm going to say that if they chose number 1, it would be soup. Now we have to figure out though, because if they didn't choose 1 and they didn't choose 2, then how are we going to return 3? Well, we need to nest another if function here. We're going to type in if, open and close parentheses. And when we do that, we have another if function now nested. So if I go over to my formula bar here, you'll see that if F5 is equal to 1, I want soup. Or if F5 is equal to 2, I want something else. Or if, and we could keep saying that. We can have as many results as we want. But let's click into this if. You can quickly switch between function argument boxes. For instance, I can click on this if, and now I'm in the second one. Or I could go back to the first if, or the second if. You can switch quickly between, and we want to be sure that we're in the second one, and we're going to write the next question. If F5 is equal to 2. It's still not. But if that was true, if it was equal to 2, it would be, let's say, a sub. Now that we've done 1 and 2, right? We're saying If f5 is equal to 1, it's soup. Or if f5 is equal to 2, it's a sub. Since we only have 3 results, we can now just fill in the false. If it's false, if it's not 1, if it's not soup, or if it's not 2, it's not a sub. Well, then what could it be? Well, then maybe it's a salad. So I'll type in salad. Now, if we had more than 3, we could keep going. We could just put another if inside of here and just keep going with this. But essentially, this is what it's going to look like now. We're going to say, okay, and we get salad. And if we look at this entire formula now, we see that if f5 is 1, write soup. It's our first one. Or if f5 is 2, write sub. That's our second one. And then if it's not soup or if it's not sub, well, then it can only be one other thing because we only have 3 items: soup, sub, or salad. And that's how we can nest if functions. So now, click and drag. Anytime it says 1, it's a soup. Anytime it says 2, it's a sub. And anytime it says 3, it's a salad. Database functions like SUMIF, COUNTIF, and AVERAGEIF allow you to sum, count, or average cells in a range that meet your criteria. Let's say that we have this parent company Q1 expenses. We have the division, the category, and the total expense. If I wanted to be able to type in, let's say, software, and it will tell me how many invoices we have for that bill, what the total is that I have to pay, and also what is my average expense. In order to do this, we can use SUMIF, COUNTIF, and AVERAGEIF. And we can say that I want to summarize or count or even average based off of this category criteria. So if it says software, I want you to count. If it says software, I want you to summarize them. Or if it says software, I wanted to average them. So we're going to use that SUMIF, COUNTIF, AVERAGEIF, starting with total bill invoices. I'm going to do equals, and since I just simply want to count how many bills we have, we'll use the COUNTIF function. Now, when we start typing out COUNTIF, you'll see 2. You'll see COUNTIF and COUNTIFs with an S. COUNTIFs with an S is if there's more than one criteria. There's only one criteria, category. Whatever it says in F5, that's what we're counting. So we only need to use COUNTIF. If there was 2 things here, like category and division, well, then you can use COUNTIFs with an S. But since there's only one, we'll use COUNTIF and press Tab to open up the parentheses. Now it's only asking us for 2 things, and I'll grab my little function arguments box here. It's asking us, well, what is the criteria? And the criteria is whatever's in this cell here. Right now it says software. And then it's asking, well, where are we looking for software? And we're looking for it in this list of categories. So what it's going to do is it's going to look for the word software. It'll go through, find it, and it'll count it because we're using a COUNTIF. So if it says software, count it. So that'll be 1, 2, and it'll keep going through and count how many invoices we have. So to do that, first thing I'll do is criteria F5. Where are we looking for it? The range from C5, Control-Shift down arrow, to C62. I'll then click OK. And there it is. We have 4 total bills for software. The next thing I want to see is how much do those 4 bills equal out to? So I'm going to do a total expense. Now in this case, if I want to see the sum, I'm going to use a SUMIF. So I'll do equals SUMIF. And once again, you'll see 2 options, SUMIF and SUMIFs. Since we're only using one condition, we're going to say SUMIF and press the Tab key to open. For SUMIF, it's going to ask us for 3 things this time, unlike COUNTIF. It's asking us for, once again, the criteria, which we know is going to be F5, and it's also asking us for the range, which we know is going to be from C5 to C62, But now it's asking us, well, when we find that range and that criteria, what do you want us to summarize? And we're going to say we want to see the total expenses from D5 to D62. So what it's doing is it's going to go through here. It's going to say, okay, we're looking for software. Once we find software, find it, there it is, we're going to take this number next to it. And we're going to sum it because we're summing using SUMIF. It'll then look again, software, find it, and then add it to this number. And that will give us our total, which is great. So that's exactly what we're going to do here. The criteria is, once again, F5. Where we're looking for that criteria is from C5, Control-Shift down arrow, to C62. What do we want to add together? The total expense from D5 to D62. Now we'll click OK, and we get our total expense. Now, if you want to change this formatting, you're more than welcome to. I typically do. Remember, we can always change the format by going to the Home tab, the number command group, and I'll just change it to look like a currency. I now want to do the average expense, and the average is going to be identical to the sum if. The sum if we selected F5 as our category or our condition, we're looking for it from C5 to C62, and we're totaling up D5 to D62. All of this will be identical in our average if, because all we're doing is just changing it from sum to average. So you're more than welcome to copy it, but just to do it and kind of get our practice, let's just write it out. We're going to do equals average if. We'll select average if, press tab to open the parentheses, grab that FX box if you like, criteria, F5, the range, C5 to C62. The average that we're looking for, D5 to D62. Click OK. And you can change it to a currency if you want to. And look how awesome this is. Now we get our total bills, the total that we have to pay, and on average what we pay. If I want to change this, let's say I want it to be rent, now it tells me what my rent would be. Or supplies, now it tells me my supplies. Now I do want to add a little bit of an extra bonus here. If you've seen any of my previous videos on Excel 365, in our intermediate video, we learned about data validation. And there we learned we can create a list. Now I want to do that here because, well, to be honest, I'm a horrible speller. So trying to spell this out in F5 each time, like if I wanted to look at maintenance or technical support, that could take a lot of time to do. So instead, I'm going to create a list here with all of our categories. So the first thing I'll do is click into F5, go over to the Data tab, and inside of the Data tab, we're going to go over to the Data Tools, and we're going to click on Data Validation, which is the little check mark / deny sign. It'll pop up this dialog box. Right now in F5, there's anything allowed in there. I'm going to say that I want to put a list in there. And you can either write out the list or you can reference cells. And that's what I'll do. I'll say from C5 all the way to C18. I'll click OK. And now we have a fun little list. And how awesome is this? And one of my favorite things about 365 version of lists is that they're searchable. So if I start typing out an S, it starts to pull out the S. Or if I type out, let's say, a C, it pulls up everything with a C. Pretty cool. And now I can just quickly select from the list. And there we go. GoalSeek is an amazing feature. And what it does is it finds the input needed in one cell to arrive at the desired output in another cell. So let's say that I'm just trying to find what my price estimate would be. I'm going to just take a moment to zoom in on this, and you'll see here that we have the info, which is what the price is for the product, how many units I sold, and the total amount I made. Now, in order for GoalSeek to work, we need to set up a formula over here in the total, which I already did for you. All I did was C5 multiplied by C6, and that's going to give us our total. But what I'm trying to find here is I know how much money I want to make. I want to make at least 250,000. If I sold all the units I have right now, let's say that I have like 12,000 shoes. If I sold those 12,000 shoes, how much would I have to sell each one for to get to 250,000? We would have to do that math ourselves. But since we have Excel here, why not just use Excel? So the first thing we need to do is set up our price estimate just like this. We then go over to the Data tab, and inside of the Data tab, we go over to what's known as the Forecast command group. We're going to use what's known as the What If analysis. This allows for us to take a look at different scenarios. You'll see that we have a scenario manager, a GoalSeek, and also a data table. And the one we're using is GoalSeek. I'll click on GoalSeek, and it's going to open up this dialog box. It wants to know what we want to set a certain cell to. I know how much I want to make. I want to make 250,000. So I know I'm going to set C7, and the value for C7 is going to be 250,000. That's what we're trying to get to. But we're going to try to get to that goal of 250,000 by changing the cell. And the cell we're going to change is the price, because I don't know what the price could be. I want Excel to figure that out for me. So I'll select C5. Once I fill this out, I'll then click OK. It'll run through the different scenarios, and it'll say that if I want to make 250,000, I would have to sell each, we'll say shoe, for $20.83. If I sell each shoe for $20.83 and I sell 12,000 of them, I will reach my goal. So now I know what the price is for each shoe. And as you can see, this is very helpful for me because I don't have to do the math myself. I just allow Excel to do it for me. We can also do this the other way around. Maybe we have the price and we want to know, okay, if I'm going to sell the shoes for $59.99 each, how many shoes do I have to sell in order to reach my goal of 250,000? So once again, we'll set it up where we have the price. We don't know how many we want to sell. That's what we're trying to figure out. And we have our formula. You always need that formula in the total. Price multiplied by units sold. I'll go back to data. In my data tab, I'll go over to the data tools again. Right next to it is our forecast. And we'll click on what if analysis. Once I click on that, I'll select my GoalSeek. It will pop up that same dialog box. We're going to set H7, wherever our formula is. We're going to set that to 250,000. This time we're changing whatever's empty, which is units sold, which is my H6. I'll then click OK. And there we go. It says that we should sell about 4,167 units. That's how many shoes we would have to sell to make our 250. So as you can see, GoalSeek truly helps us out to figure out how many things we need to sell or how much we can price it out. There's so many other applications for this. In this section, we're going to be talking about PMT data tables. Now, PMT is a function in Excel that will calculate the payment amount required to pay off a loan. And it requires for you to specify the number of payments you're going to make and also what is the given interest rate. So you'll see here I set up our total for the loan, which is $6,500, the interest rate that we got approved for, which is 22.3%, and our projected payment period, which I'll say 2 years, 24 months. Now, in order to calculate what our monthly payments will be, we're going to use PMT. After that, we will then use a data table, which will then take all of our original formulas and replace whatever we choose with one of these values and then return the results. That way we can see what if we paid it off in 6 months instead of 24, or 10 instead of 24, or 15. So I'm going to click into B8 and we're going to write out our first formula. We'll do equals PMT, press tab to open the parentheses, and click on the FX. Now once we get the function arguments box, we only need to put in 3 arguments: the rate, the MPER, which is the total number of payments we're going to make, and the PV, which is the present value. The rate is always going to be divided by a certain period of time. So for instance, our rate is in B4, but we want to see how much would it be annually, so we're going to divide it by 12. If you were doing quarterly payments, you would divide it by 4. Or if you were doing biannual, you would divide it by 6. Since it's 1 year, it's 12 months, we're taking B4 and dividing it by 12 months. The NPER is going to be the total number of payments we're looking at right now, which is 24. And the PV is the present value for the loan, which is in B3, 6,500. Once we put all of those in and we click OK, we now get how much our monthly payments are, which they're about $338. But what if I didn't pay it off in 24 months? What happens if I paid it off in 6 months, or 10, or 15? Well, that's where the data table will come into play. The data table will show how the changing input, which would be 24, it'll swap it out to 6, and then it will output the result. In order to do this, we need to first select the entire table we created. So from A8 to B15, we'll go to the Data tab, and inside of the Data tab, we'll go over to the Forecast command group and choose What If Analysis. Once there, we'll choose Data Table, and it's going to ask us, well, do you want to do a row input cell? Is that where you're switching them out? Are they going across the rows, or are they going down the column? And I'll choose column input because this is where our months are going down. And what this is going to do is it's going to say, what do you want to swap out? Well, I want to swap out B5. So it's going to look at the original formula, see that the 24 is there, the B5. It's going to swap it out with A9 and give me it in B9. It'll then do the next one, A10, give me the result in B10. So when I click OK right now, there we go. So if I was to pay this off in 6 months, I'd be paying about $1,154. Now if we take a look at this, we can see how much we're actually paying here. So for instance, if I'm going to do equals, let's say 6 months multiplied by how much we're paying each month, I'd be paying $6,929. That's with that 22% interest. So we're paying about a little over $400 in interest. If I was to pay this off, though, all the way 35 months, take a look at how much I'd be paying. If I take longer to pay this, and I multiply it by our $254, I'm paying $8,899. So I'm paying about $2,000 in interest, a little more. So it is safe to say that paying it off quicker is going to save you more in interest. But we can see here that now we can create a little table here too, showcasing how much our total loan would be if we paid off quicker or longer. What we're going to be talking about next is macros. Macros allow for you to record and play back a sequence of routine commands and actions, automating repetitive tasks. In order to actually use a macro, though, we need to be sure that we turn on our Developer tab. So the first thing we're going to do is right-click on any of the tabs, go to Customize the ribbon, and then over here on the right-hand side, we'll then choose the Developer option and make sure you give that a little check mark. Once you check mark that, you'll then click OK, and we now have our Developer tab. Now the first thing we're going to do here is we're going to start to record a macro. We'll talk a little bit more about VBA coding, and we'll even build out some code in the next section. But for now, we're going to click on Record a Macro. What this does is it records the macro, and then it turns it into code, and then we can run it, and it will automate a process. We're going to call this one sign-in sheet. Now, it's important to note that when you're naming any type of macro, you don't add any spaces. So I'll do sign underscore in underscore sheet. If you use spaces, you'll get a syntax error. So if I backspace and put a space and I click OK, it'll tell me that's the incorrect syntax. You can't include spaces or characters. So that's why I like to use the underscore. Once you do that, you'll then choose a keyboard shortcut. Now, if you put an S here, that Control S actually saves the workbook. So it's already a keyboard shortcut that's been assigned by Microsoft. Macros are so powerful that if you did do Control S, it would replace the save function. That's something we may not want to do. So it's important that when you're choosing a keyboard shortcut, you choose something that's not known. Or you can also hold down the Shift key and press S, and now you have to hold Control Shift S in order to run this macro. So that gives you more of a variety of options. You then choose where you want to store this macro. We're going to choose this workbook and give it a quick description. I'll say that this creates a sign-in sheet. Now, the minute you click OK is when it starts to record every single movement you make. So I'll click OK, and it's starting to record, and if you want to stop recording, you can click on Stop Recording. But let's create this worksheet first. First thing I'll do is call it sign-in sheet. I'll add some style to it, so I'll go to Cell Styles, and you can choose whatever you like. I'll choose Title. I'll then put in the date. I'll use equals today function, and the reason I'm doing this is because today it will put today's date, tomorrow it will put tomorrow's date, and so on and so forth. So I'll do equals today, and then at this point, I'll then choose a style. So let's do heading 4. And I might just merge these together. That looks good. Now for the sign-in sheet, I'm going to have an ID, or even just a numbering system. You could call it num, ID, the name of the person, and then also, let's say what department they're in. And then I'll just turn those into little headings here. I'll then put my 1, and I'll use autofill here, so I'll hold down the Control key to have sequential order, and we'll put in about 20 spaces. I'll make this a little bigger, make this a little bigger, and now I have my sign-in sheet. Now I'll go back to the Developer tab, and I'm actually going to stop recording this process. And now I've created a macro. Now, if you actually want to see the macro, you're going to go over to Macros and give that a click. Once you click on that, it'll show you a list of all your macros, including your sign-in sheet. You can quickly run this code, use the keyboard shortcut, edit the code in our VBA, which is Visual Basic Applications, delete it, or take a look at other options. But let's see if this works. I'm going to just delete everything out. I'm going to click here, and I'm going to use Control-Shift-S. And how awesome is that? It creates our sign-in sheet right away. And I can do this every single day with an updated date and a clear, up-to-date sign-in. If you want to take a look at what the code looks like, you can go back to Developer tab and open up the Visual Basic Applications editor. Once you click in there, you'll see here, this is our Microsoft Visual Basics for Applications, VBA code. And if you're wondering what VBA code is, it's a programming language that's built into Excel. It allows you to create customized macros, functions, you can automate process, or even integrate with external data sources. It's really great for automating complex and multi-step processes. Now if I go over here to my modules, you'll see here that we have a module 1. If you just double click on it, it'll open it up here. And this is where you'll see your actual code that was written out by the recorder. It tells you that it's called sign-in sheet, it tells you what it does, and even the keyboard shortcut. And then it runs through the code. Now this code is pretty strict because it was made by a computer. So a computer coding, this is what it looks like. When we learn about coding our own applications in a little bit, you'll see that our code's going to look a little different than this, less formal. If you want to exit out of this, you could just go to the top left-hand corner and you'll see that we can go back to Excel. Click on the little Excel icon and it brings you straight back into the worksheet. As we just saw, recording macros is really amazing. It allows for us to automate processes. But there's so much more to VBA coding. It is a programming language. What I want to showcase next is using if statements. Macro if statements allow for us to, based off of a condition or criteria, execute a certain line of code. So in order to do this, the first thing we'll do is go over to our developer tab. And inside of the developer tab, we'll go over to the code command group and choose Visual Basic. Now once we click into there, you'll notice that we have our module 1 from before. And if you want to create your own new module, you're more than welcome to. I'll just exit this one. We're going to go up to the top. You'll see under the second little toolbar here, we have a little drop down. And we can click on module. Once we click on that module, it'll create a second module for us where we can start writing our own code from scratch. Now when it comes to coding, we always want to be sure that we use the keyword sub. And sub means subroutine. So essentially we are running through a subroutine of code that will allow us to accomplish anything. Whether we want to automate a process, maybe we want to create a new function, or maybe we want to define some sort of solution to a problem. We can do that. We're going to create our own code today. I'm just going to call this sub fun. Right? We'll then do an open and close parentheses and press enter. Now the minute you do that, it's going to show up with an end subroutine. That's just Microsoft helping you out. So sub fun, we're just saying the subroutine's name is fun, and then we're ending the sub after we write our code. Now before we just start writing code, it's important to know that we are the masters of this language. The first thing we're going to learn about and see right now is something known as a variable. A variable allows for you to name something in your code. You can name it whatever you want, and then it will reflect inside of the code so that you don't have to constantly write it. For instance, if I wanted to write a full sentence saying, "Hello, how are you?" I might call it variable x. Anytime I say x, that means, "Hello, how are you?" That will help me out so I don't have to constantly type, "Hello, how are you?" I could just type in an x. So the first thing we're going to do here is create a variable called MSG. And when you're naming variables, it's usually relative to what you are saying, right? MSG is going to be my message. And my message is going to be, let's do, is your name Joe? You'll notice that I put it in a string of text. Very similar to the way we write functions, we have to have strings of text. So we have to have our quotes around our sentence. Now that I have MSG, which means is your name Joe, anytime I say MSG, it's asking that question. I'll create another variable here called ANS, which is, well, standing for answer. And remember, you can name this whatever. You could just call it an M is equal to or A is equal to. But I just like to name things a little more so that when I read my code back, it's more readable for me and I remember what I was trying to do. I'm going to create what's known as a message box, and this is some pre-built-in code that Microsoft gives us to get our jobs done in VBA. I'm going to do MSGBOX, just like that. And I'm going to open up that parentheses there. It's sort of like filling out function arguments. It's asking us, well, Joe, we're going to create a message box for you, but what do you want the message box to say? I want the message box to ask the question, is your name Joe? And once again, I now don't have to write, is your name Joe? I could just write MSG, just like that, and put my comment. Now, when it creates a message box, it's just a pop-up box that you would see in Excel, and it's going to have, is your name Joe? I need a way for the person to say yes or no. And we're going to use what's known as VB. These are our virtual buttons, and we're going to choose VB yes no. So just scroll down to the bottom and create VB yes no. So virtual button yes no, and close the parentheses. All this is doing so far right now is just creating a box that says, is your name Joe? And it's creating a button here that says yes or no. So that's all this code is doing so far. But now we need to figure out, well, what happens if they hit the virtual button yes? What will happen? And that's where we're going to use this if statement. We're going to say if A and S is equal to VB yes, so if they hit the yes button, then we'll create a message box. Let's just do a message box that says something like, so is mine, that's awesome. Something very simple, that's it. And then we'll create another if statement because, well, if they don't hit yes and they hit no, if A and S is equal to virtual button no, they hit that one, well then I want them to create a message box. And that message box will say, you are still awesome. And that's it. So really we're just creating a message box with the message, is your name Joe? With a virtual button that says yes or no. If they hit that virtual button yes, well then the message box will say, so is mine, that is awesome. If they hit the virtual button no, then the message box will say, you are still awesome. Now that we've created this code, we can see if it's going to work. We'll run it. We're going to go back to Excel. Remember, we can hit Alt F11 or just click on this button. And now in our macros, we'll click on our macros. We'll see the fun macro, and we can quickly run that macro by clicking on Run. And look, it pops up a dialog box. It says, is your name Joe? Oh, yes, it is. So is mine. That is awesome. And we click OK. And look how fun that was. We can run that again just to see what it would say if we click No. You're still awesome. And there we go. That is our first code. And that is an if statement code. You'll always see that when you use an if statement, it's going to be if, then. If, then. So as you can see, you could probably come up with a couple of ways that you can use a code like that. Another concept in VBA coding is loops. And today I want to show you the do until loop. A do until loop tells a macro to repeat a certain section of code over and over again until the condition is met. So it says do it until it evaluates to true. So we're going to do a fun little code here. This one's going to be very similar to like autofill. So feel free to click the little plus icon and open up a new worksheet. We'll then click on the VBA, and you'll see that that's going to be in the Developer tab, Code Command Group, and we'll choose Visual Basic. You'll see our code from our previous section, and you're more than welcome to continue to code here. You don't have to open up a Module 3, for instance, to write your code. I could just click down here, do a couple of enters, and then I'll write my subroutine name. Remember, we'll do sub, and I'm going to call this sub, let's say, do underscore until underscore example. Open close parentheses. And when you press enter after you name this, it will put a line between the previous code and your new code, and also give you your end subroutine. Now, one of the things I didn't talk about in the last section was being able to tell the VBA code your dimensions. Dimensions are important because it allows the code to know exactly what you're going to be utilizing, whether it's a string of text, or whether you're going to have a long number, or maybe it's going to be an integer. And the way that we do that is we write dim for dimension. We're going to say that the dim of x, and then we're going to write as, and you'll see here that we can dim it as many different things. Maybe I want to dim it as, let's say, an integer. So you'll see integer. Or maybe I want this to be known as a float. Or maybe I want this to be a long integer. Or maybe I want it to be a string of text. We're going to say that we want this to be long. So we're going to dim x as long. It's going to be a long number. We're then going to say that x, as of right now, is equal to 1. So x is equal to 1. And I want to do this until x is equal to 11. So I want to keep running this code. So I'm going to use a do until x is equal to 11. So I'm going to keep running this code until x equals 11. I'm then going to select a cell to run this code in, because I actually want this to display something in Excel. So I'm going to say that cells, and in Excel, when we're doing VBA coding, it's no longer AB or A1, B2. It's now all numbers. So for instance, A1 is now 1, 1. B1 is now 2, 1. So we're going to choose the row index, and the row index is going to be 1. But I want that to keep going down the rows, so I'm going to say x, because x will change. I want it to all stay in one column, so I'll put a comma, and I'll do 1. Then I'm going to close that, and I'm going to say the value of cell x1, which is really A1, the value of it is going to be equal to x. So all it's saying is right now, x is equal to 1. I'm going to keep running this code till x is equal to 11. I'm going to select cell x1, which is A1, and the value of A1 is going to be 1. Now I'm going to run another thing saying that x is now equal to x plus 1. That way we actually add to this. And I'm going to loop this. So what's going to happen in this code? It's going to run through x is equal to 1. It sees that it can keep doing this until it equals 11. Cell 1, 1, which is A1, is equal to 1. Then it says x is now equal to 1 plus 1. So now x is equal to 2, and it loops again. It keeps doing it because x is equal to 2, so it can continue. Cell 2, 1. So that's A2 is equal to 2. X is now equal to 2 plus 1, which is 3. It loops again, and it keeps doing this over and over until eventually it'll get to 10. 10 plus 1 is equal to 11. It'll loop and it'll say, oh, it reached it. Now we're going to end. So that's why a loop can be very helpful. It can keep iterating through these different scenarios over and over until it reaches true. Now what we'll do is I'll click over to View Excel. I'll go to my macros, and I'm going to run this example. And when I run it, how cool is that? It runs through and it puts 1, 2, 3, 4, 5, 6. So it's kind of like autofill. And it does this because it keeps running through. And I can make that go for thousands of rows. I can go back and edit my macro. And I can say, keep doing this until we reach 999. And I can run my code over and over again. So now I'll click here, run my code, and there it goes. And if we scroll all the way down, should have went to 998, because once it hits 999, it stops. So pretty cool code. It's kind of like autofill, but that's a great example of how we can use it and keep looping or repeating our macro over and over and over again until it meets a certain condition. Now that we learned about if statements and do loops, what I want to do is combine those together and create a fun game for us. So the first thing we're going to do is open up our Visual Basics again. And remember, we can do that by going to the Developer tab, heading over to the Code command group, and clicking on Visual Basic. Once you click into Visual Basic, we'll then use the same module 2 here that we used in our previous two examples, and we'll just space it down a little bit. We're going to name the subroutine. We're just going to call it subgame. Open close parentheses, and press enter. So for this game, what we'll do is use an if statement and a do loop to choose a simple game, and that simple game is going to be a guessing game. Guess a number 1 through 10. And if you guess it right, well, then it exits the game. If you guess it wrong, you got to retry. So the first thing we'll do is let's dim x as an integer. So we're going to have a variable called x, and it's going to be an integer. And then I'll put a comma. I'll also have an integer called a, and a is going to be integer. So we have a variable x, variable a. Now we're going to say that x is equal to the number. We have to pick a number 1 through 10. So we need a random number. Now if you've used this function before in Excel, it's known as the rand_between function, and it picks a random number between two numbers you choose. So in order to use it in VBA coding, we're going to call this worksheet function. So we're saying that, hey, VBA code, we're actually going to use a worksheet function from Excel. So we say worksheet function dot, and then you'll see all the different functions we have access to. Some of them you might have seen before. And the one we're using is rand_between. Once we choose rand_between, it works like a normal function. We do an open parentheses, and we put in the two arguments. The two arguments are, what is the beginning number? We'll put a 1. And what do you want to choose to? A 10. And then close the parentheses. So x is just a random number now between 1 and 10. It could be 1, 2, 3, 4, 5, 6, 7, right? Now we have to create a do loop. So we're going to do our do, and we're going to say that a is equal to an input box. So just like we did a message box in our previous section, an input box is similar, except somebody can input information into it. And we're going to ask a question in this input box. We're going to say, Joe is thinking of a number between 1 and 10. What is it? So it's just going to pop up a box that asks this question, and then you'll be able to input an answer, and that will become A. Now, if A, right, if their answer, which could be 1 through 10, is equal to X, well, then it's going to exit the do. It's going to exit this loop because they would have guessed the number and they would have won. But if they don't, if X is not equal to A, well, then I want to create a message box telling them they got it wrong and to try again. I'll say, try again. And I'll keep looping this. So I'll write my loop like we did last time. So all it's saying is, X is a number 1 through 10. It'll change every single time. If A, which is whatever they input, is equal to X, then exit the do. And we can write a message down here underneath loop. We'll say, create a message box that says, yay, you and Joe are connected. And you can write whatever you like there. So if they guess, they exit the do, they exit this entire loop, and they go straight here and they win. But if they don't, well, then it's going to create a message box saying try again, and it's going to loop it back here, and it's going to create another input box saying, try, Joe's thinking of a number. So this is a fun little game. We have our loop, and if they win, then it exits the loop. And let's see if this works. We'll go back over to Excel, macros, and let's run the game. Joe's thinking of a number between 1 and 10. What is it? Is it 5? Try again. Joe's thinking of a number 1 through 10. What is it? Is it 8? Try again. And then I can go through and see. It's not 7. Is it 6? Is it 4? Is it 9? Yes, it was 9. Yay, you and Joe are connected. So this time it was 9, but because it's random, you can play the game every single time. Because if I run the game again and I put 9, it's not it. So we can keep having fun with this game over and over again until we guess. You can get more complex on this game as well, by the way, if I decide to say something like, let's do 3. Which one was it? 2? Did we run through all the numbers yet? Maybe it was 9. I don't know what number it was. You can keep doing this, and you can add some really fun things where maybe you want it was 5. Maybe you want to add in if they're close or if they're not close, or maybe you want to add in the number of tries they have. They can only have 4 tries or 3 tries, but you can get more complex with your codes. Have a lot of fun with this though, and you can probably start to think of ways you can use do's or ifs. I hope you enjoyed our Excel 365 Advanced series. We've just scratched the surface of some of the advanced functionality Excel has to offer, whether it's analyzing data or modeling what-if scenarios, or even automating workflows with macros. Excel is dedicated each year to really just improving some of the functionality that we have. Excel can add so much to business use cases, and I truly hope this overview provided a helpful launching point as you explore further according to your needs. Thanks.
Thanks for watching. To earn certificates and watch our courses without ads, check out learnitanytime.com.